guys, welcome to this video on the topic of second order differential equations. Now what you might be able to see, should be able to see up on the screen here is an example of a second order differential equation. Now the reason once again why it's a second order differential equation is that you might be able to see here we've got a second derivative here. So a second order differential equation is one that contains a second derivative, and it might contain a first derivative and the original function as well. Okay, so this is an example of a second order differential equation. Now there are two particular things we need to look at here. One is going to be solving relatively simple second order differential equations, and solving means trying to find out what the original function was equal to. So it's not finding a numeric solution, it means finding the original equation. Now the other kind of question that is typically asked is to show that something is a solution, and that's actually the example I'm going to start off with here. So let's say we have a function y equals x times e to the power of 2x, and we're asked to show that that is a solution. Now there would be two typical approaches to this. We could try and solve this and end up with the solution, or more typically, and this is the usual approach in this kind of question, we actually substitute the original function to here, the first derivative here, and the second derivative here, and in this case when we calculate the left hand side we should be getting 0 because that's what we're told it is equal to. So that's what we're going to start off with this example here. So this is our original function. Let's get our first derivative. Okay, so this is the product of two functions, so I'm using the product rule, so treating x like function f and this exponential like function g. So f dash g would be e to the power of 2x times 1, or just that, and then plus the derivative of this exponential would be 2 e to the power of 2x times function f, which is times x, and let's just write that slightly more tightly. And now our second derivative. Okay, so deriving this function here, because that's just a straight function, so we just need to derive that, and then this, and on this part we'll need to use the product rule again. So starting with this bit would be 2 e to the power of 2x. If you're not too clear about where that came from, look back on how to derive exponential functions, which is itself times the derivative of this part here because of the chain rule. Okay, plus now, so once again product rule, f dash g would be 2 e to the power of 2x plus g dash, which would be 2 e to the power of 2x times function f, and let's tidy that up. Hopefully you're noticing that these are two like terms here, so that will simply be 4 e to the power of 2x plus 4x e to the power of 2x. Okay, now we've got our original function, our first derivative and our second derivative. Let's go back to this statement here and show, hopefully, that when we substitute into the left hand side we end up with 0, which is what we're expecting to get. Why? Because we're trying to show that equals 0. Okay, so substituting. Okay, second derivative. Minus 4 times the first derivative say it equals 0 at this stage. We're trying to show that it does equal 0. So the only way to proceed here is to expand out. And hopefully we find a lot of things cancel out. Well, I've got, let's see here. That is 4e to the power of 2x, and that's negative 4. So those two are going to cancel. That's 4x e to the power of 2x, and another 4x there, so that's 8x e to the power of 2x. Take away 8x e to the power of 2x, so they will cancel, and that equals 0 as required. Therefore, this is a solution. Okay, so there's one kind of question where we have a differential equation of second order one in this case, and we're asked to show that this is a solution, and that's how we would typically proceed. Take this, find your first and second derivatives as required, substitute them into the left hand side, and show that we get the right hand side. Okay, let's have a look at a second kind of question. So I'm just going to make a new page, and this second question is one where we're actually asked to solve the second order differential equation. So I've got a second derivative, and it doesn't have to be in Leibniz's form, it might be in Newton's form like this one here, and this is a trig function. So let's say we are asked to find the general solution. Now, general solution will be one where you've still got the constants of integration left in your solution. Okay, so I'm going to start off straight away getting the first derivative. I get that by integrating. Now be really careful here not to take 32 out as a common factor of everything, because it's only a factor of this part. So in fact I'm just going to leave that 32 there. Now integrating, we'll have the integral of sine is negative cosine, and we've got that 4x, so we're going to end up with negative 1/4 cosine 4x, or the integral of that, and there's a 32 already in front, so I'm going to end up with 32 over 4 and negative cos 4x. And then the integral of 8 will be 8x, and then we have a constant of integration. Just tidying this up. Now some of you guys struggled with integrating trig functions still, and the only thing I can recommend there is either you're asking me questions about it, or you are practicing this more so that the patterns become ingrained. And if you're not too sure where that quarter comes from here, for example, you really need to practice this more. Go back to that section on integrating trig functions and simply practice it more, and ask me questions where you need to. Simply saying I don't understand it is going to get you nowhere. You need to do something about it. So get off your butt and actually do some practice. That's if you're struggling with this. Okay, so let's just check the solution here just to make sure we do get back to this. So it'll be negative 8 times the, now I'm deriving here, so the derivative of cosine's negative sine, so it'll be negative sine 4x times 4, so the 4, negative 4 times the negative 8, yeah, we get 32, positive 32. So you can check that for yourself, but I'm just doing a rough check in my head here, and yes, that derives to give this here, so we're on the right track. Okay, first derivative. Okay, so once again we're going to first derivative, back to the original function I should say. So we're going to be integrating once again. And all of that with respect to x. So integral of a cosine function is sine. So this should be, I think, negative 8 over 4. Once again, why the 4? Because we need to compensate for that times 4 that we get from deriving that with the chain rule. Okay, sine 4x plus, integrating 8x will be 8x squared over 2, and integrating a constant becomes the constant times x plus some other constant, I'll call that other constant d. Okay, so this is going to be negative 2 sine 4x plus 4x squared plus cx plus d. Okay, and once again, if you check that by deriving this, now the derivative of sine is cosine, so it'll be negative 2 cosine 4x times 4. Okay, and that would be 4 times the negative 2 will be negative 8 cosine 4x, which is what we've got here. So here we've got, I think, our general solution. Okay, now sometimes, quite typically in fact, you're asked to actually find the particular solution if we're told some extra information. Let's say that we're told that when you substitute pi over 8 into the first derivative, we end up with pi, and that we substitute 0 into the original function, we get 1. Now what we're going to need to do is we're going to need to take this bit of information here for a start and substitute it into here so that we can find out what c is. Okay, so I'm going to do that. So pi over 8 is equal to, why pi over 8 in front? Because our first derivative is equal to this. So when I substitute, oh sorry, that is a mistake. When I substitute pi over 8 into the first derivative, it equals pi. So that should be pi equals this. So pi equals negative 8 cosine 4 times pi over 8 plus 8 times pi over 8 plus c. So pi equals, right, 4 times pi over 8, that would be pi over 2. The cosine of pi over 2 is 0. And negative 8 times 0 is still 0, so that part becomes 0. 8 times pi over 8 becomes plus pi plus c. Well, we've already got pi here, so plus nothing still is pi, so c must equal 0. So our first derivative is equal to negative 8 cosine 4x plus 8x plus nothing, because c we just found it to be 0. Okay, now using this piece of information now, okay, coming back to our original function here, now that we know that this part c is 0, I can now go back to there and say, right, 1 must equal then negative 2 sine, and I'm putting 0 into the original function, sine of 0 plus 4 times 0 squared plus d. Remember this part here, cx becomes 0 because we've just found c is 0. Okay, so what are we going to get here? 1 is equal to, the sine of 0 is 0, so that's 0 plus 0 plus d. So d is equal to 1. So our final particular solution, our original function, negative 2 sine 4x plus 4x squared, the cx is 0, x is 0, and D we just found is 1. So here is our particular solution. Right guys, so there's a couple of examples. Once again, if you do have any questions, please email me that. And secondly, I will put one question in here just for you guys to have a go at, to try and see how you're getting on with this kind of question here, this second kind of question. Okay, so we'll catch you in class tomorrow.